this is the last little bit of this unit, so you will see how everything kind of just comes together, and there isn't really much of like new content you're going to learn. It's maybe just a little bit of a different approach to the same things you've been doing already, and some terminology that you have to get familiar with. Okay, so I basically today I'm going to show you how to graph using the intercepts and finding a third point if it's needed, right? So I have my highlighter ready to go here, and we're also going to do some rate of change here as we go along. Okay, so any graph of a line that is not vertical, right? Any graph of a line that's not vertical is a function. So basically, whenever you see a linear, a line, like a straight line, it is a function because it doesn't violate the vertical line test, right? We call this linear. Just 1 second here. I'm gonna make sure I'm linear functions. We can use the intercepts, right, to describe the graph of a linear function. Okay. So we're looking at this graph right here, and you have what we call the horizontal axis or the x-axis, right? Also, the independent variable is along the x, and this is the y-axis, right? No news there. So this graph intersects the horizontal axis at, so this would be at 2, right? It's right there at 2. So the horizontal intercept is 2. The coordinates of this horizontal intercept, right, is 2, 0, of course. Okay. We call this also the x-intercept. That's what you're going to hear me say a lot more than the horizontal intercept. You're going to hear me say the x-intercept a lot more. Okay. And notice that y is equal to 0 at that point. No matter where it would hit along the x-axis, y is going to be effectively equal to 0 at that point, right? And then on the other hand, this graph intersects the vertical axis at 5, right? So it intersects the vertical axis right here up at 5. Okay, so the horizontal intercept is 5. The coordinates of this point is 0, 5. And this is called the y-intercept. That's when the line intercepts, right, the y-axis. There's one thing that's that I don't like about these graphs. Like the implication is that it goes on indefinitely. There should be arrowheads if that's the case. Okay, so your graph should include arrowheads unless it's a word problem where it's definitely just contained like that. If you're just graphing an equation and there's no context around it, you should include arrowheads. Okay, no context, include arrowheads. Okay. When working with variables x and y, we call the horizontal intercept the x-intercept and the vertical intercept the y-intercept. And they have a specific meaning to us, okay? Yes, we call them x-intercept, y-intercept, but within a word problem, it means something. So we're going to ask you quite often to tell us what is the significance of the x or the y-intercept in this particular case. Okay. Finding intercepts, domain, and range of a graph. This graph shows the temperature in a location over a 12-hour period. Find the vertical and horizontal intercepts. What do they represent? The x-intercept would be, you go over here, and the x-intercept is 4, right? It's right there. And that is actually, if you were to write this as a coordinate, that'd be 4, 0. Okay? So this point right here is 4, 4, 0. The y is 0 at that point. The y-intercept is right here. If you look at the scale, this is a scale of 2, so this would be -6 here, right? So the y-intercept is -6. Okay, so that would be 0, -6. Notice how the x is equal to 0 at that particular point, right? So how can we describe them? Well, we can say that, I will say here, after 4 hours, the temperature is 0 degrees Celsius, right? So after 4 hours have gone by, if you just look at the coordinates, right? After 4 hours, temperature is 0 degrees Celsius. Okay. The y-intercept, if you look at it, it's time 0. The initial temperature time is 0, right? Is -6 degrees Celsius. Okay, sorry, it's a little small, but we have a word for what happens at the beginning, right? The initial temperature. So when time is equal to 0, your temperature is actually -6 in this particular scenario, right? So that would be midnight if you want to, perhaps midnight. At midnight, this would be -6. We don't know when time 0 is in terms of time of the day, right? Okay. So make sure, sometimes it's just stating the obvious. Don't overthink it too much, right? Oh my goodness, I don't understand. It's like, just look at it. It's like, look at the coordinates. When time is 0, I actually would give you marks here. If you told me when time is 0, then the temperature is -6. You are making connections, and that's fine with me. Okay, find the domain and range of this particular situation. It's closed, right? Like it has an upper and lower limit because it's happening over a 12-hour period. Here you have to be careful. Okay, so for the domain, we'll do set notation first. So for domain, we're looking at the x values for which this graph exists. So we start at x equal to 0, and it's included, right? Because there's a full dot there. There's no open circle. You would normally use x, right? What variable do we have here now? Watch for variables. It's not x, it's t. So we have to use, if you're going to use set notation in this case, we do not use x, we use whatever variable is present on the x-axis, right? And so we go all the way to 12, right? That's the highest x value allowed in this case. And we put the squiggly brackets down. And because both endpoints are included, we can just go 0 to 12. And there's square brackets on both ends. Okay, so you can, when I ask you for domain and range, you choose. Unless I specifically state them in both ways, you choose. I would pick this one because then I don't have to worry about the variable if I have a choice. Okay, the range, squiggly brackets, I start already. I go from -6 all the way to +12. And both endpoints are included. So -6, and now the variable, oh, there's not in, there's supposed to be an H here, a T, or C, sorry, they're using C. Okay, we're gonna use C, but that's the variable there. Okay, they use C, so we're gonna use C for that one, and less than or equal to +12. Okay, so from -6 to 12, we do the same thing here. Smallest first, right? Largest second. No problem, right? I think we're good. Oh, let's put a comma in between because there it's just stating in both ways. Okay. All right, so stating the domain and range using different variables. Really, like I'm going to highlight that. Hopefully it won't smudge it there. Okay, I'm going to highlight those. So there should be no infinity here. There's no arrowhead, right? If there's an arrowhead on one end, then it's just limited on one end, not on the other. So you got to watch that. Okay. Okay. Here's I'm going to put a star here, or actually highlight this whole thing, maybe a different color so it kind of sticks out. We can use the intercepts to graph a linear function. Okay. And I'm going to put a big star because, and even the review, if you worked on the review, you might have been like, what? Right? I'm going to use the intercepts. This is just another way of creating a table of values. Okay, that's what we're doing here. We're just focusing on x and y intercept. Okay, we're focusing on the x and y intercept. So use the intercept to sketch the linear function 2x negative 4. So let's say it doesn't matter which one you find first, but let's start with the x-intercept. When the x-intercept is in question, we know this. When they tell you that, you automatically know that I know y is equal to 0. Because when it hits the x-axis, y is equal to 0. Okay, so you basically use this function to x minus 4 and you just substitute y with 0. Okay, you bring the 4 over, it's going to be positive. And then you divide both sides by 2. Whatever is in front of x. If it's a negative, you divide both sides by -2, right? Let me just focus. It seems a little blurry here on my end. Okay, maybe it's because I need more sleep. Who knows? There's x equal to 2. So you've effectively found the x-intercept. That's a point. You should be able to translate x-intercept to 0. Yeah, and then I'm going to do another one here. I'm going to now focus on the y-intercept, and x is equal to 0. X is equal to 0 when the y-intercept. So it's almost like when you're looking x-intercept, y is equal to 0. When you're looking for the y-intercept, x is equal to 0. Okay. So we start again with our function. You don't need to do this on a test. You can jump straight into substituting. What I don't like is you skipping a bunch of work and just coming up with the 2, 0. Okay. You need to be able to show how you got there. And then y is equal. And sometimes it's a little harder because you have fractions, but overall, these are actually fairly doable. Okay. So you found the y-intercept. It happens at -4. So the point we're after, the coordinate point is this. The ordered pair would be written like this. And here's what they're not asking you for, which I'm going to introduce. Find a third point. I want you to find a third point. And it's really your choice. Okay. You can choose how you want to do this. Sometimes this helps students if I tell them, put these two down already on the grid and then choose something in between. So 2, 0 would be right there. 0, -4 would be right there. So do you want to find a point that's in between here? Or do you want to find one that's further out? That's up to you. But let's say we want to find when x is equal to 4, what is the y value going to be? So we're going to say let x equal to 4. Okay, I'm wondering if x is equal to 4, what's the y going to be? Okay, because remember, the x is the independent. You get to feed whatever you want into the x, and y will be determined that way. So we're going to go 2 times 4, right, minus 4. Y is equal to 8 minus 4. Y is equal to 4. So you found a point 4, 4. And x equals to 4. It turns out that y is also equal to 4. And then so we just go find it, and it should line up. If it doesn't line up, you probably made a mistake. It's just an arithmetic error. You got to go back and check. Okay. If 2 line up but 1 doesn't, it's probably the one that doesn't that you made the mistake on, right? Like that's just how it goes. And then there's no word problem here. So make sure you extend your line way past your points, arrowheads, and on one end you put 2x minus 4 on either end of the line. That's a full mark graph right there. Could you have picked 1.5? X is equal to 1.5? Yes. Could you have picked x is equal to -2? Absolutely. Like it doesn't matter, but you got to be smart. Like I picked 4 because I knew I had lots of room here and I would be able to fit, right? You could have also picked x is equal to 1, right? Then it's just, it would be somewhere in here, right? The fact is that this is a linear because x is equal to 1. The power of x, right, is 1. You know is linear. You know you expect something like this, right? We just don't know exactly where it's going to go. Okay, so that's how you do how you graph with intercepts, and then using a third point as well. Oh, Lance is saying Google Classroom is acting weird. It won't hand and right image. Okay. Alexander James, you were saying vertical 949. Oh, this is already a while ago. Oh, I see it. I see it. Sorry, folks. This, right? Did you all catch that or no? Or are you just following me? This is, right? The graph intersects the vertical axis, 5. So this is the vertical intercept. Can you please change that? Sorry. Thank you, Alexander. Yeah, I think I caught it. If that's the one you're referring to, definitely that was a mistake. Okay. Here's an interesting one. Matching a graph to a given rate of change and vertical intercept. Okay. So the combination of rate of change and the vertical intercept, that should narrow it down, right? It should narrow it down. And the rate of change can be calculated, okay? So you pick any 2 points, and the best ones are the ones that are very clear on an intersection. So let's say this one here is, this point right here is 12, 0, right? And I'm going to pick on my y-intercept, which is way up here. That is 0, 6. Okay. So we're going to figure out which one has a rate of change of 1/2. Which of these graphs has a positive 1/2? So let's call this x1, y1, and this is x2, y2. It doesn't matter which one you end up labeling what, as long as you're consistent, okay? The rate of change would be y2 minus y1 over x2 minus x1. You just have to be very consistent. y2 is 6, y1 is 0. Okay? x2 is 0, x1 is 12. 6 minus 0 is 6. You got to watch out your signs. 0 minus 12 is obviously negative 12. You can tell that the 6 goes in here once and the 6 goes in there twice. But there's that negative that's haunting you, right? So it's negative 1/2. Okay. This graph has a negative 1/2 rate of change. But it does have a vertical intercept of 6. So that part matches, but the sign doesn't match with this. And notice that your line is decreasing from left to right. So it will be this one for sure, but let's do the math anyways. Let's pick on this point right here, 0, 6 again, and then any other point on this graph. I'm going to pick this one, 8, 10. Okay, 8, 10 is the other one that I pick. X1, Y1, X2, Y2. So the rate of change would be Y2 minus Y1 and X2 minus X1. And that'd be 4/8 positive. 4 goes in there once, goes in there twice, so that's 1/2. This is the graph that you pick. This is the one. Right, this has positive and it has the vertical intercept. Y-intercept is 6. That's another way of writing that. This is the ordered pair, the coordinate, and this is another way of saying the y-intercept, right? This is saying 0, 6. So that's the one you should pick in this case. Right? It could have been a lot easier. It could have been just by looking at it. It's like this one will be negative. I'll tell you that. You'll see the pattern. If it's negative, the line goes down. If the rate of change is positive, it's increasing, it's going to go up. So we could have narrowed it down just by looking at it without doing any calculations there. Okay, let's keep going. Here again, this is very similar to the one we did before. This graph shows how the height of a burning candle changes with time. So at the very beginning, when time is 0, right, you start with a full candle or a certain height, and then it slowly burns down. So it's going down. Rate of change, prediction, I don't know, but it's going to be negative. You know it's going to be negative because it's decreasing. Okay, that's something I want you to observe already. Find the intercepts, state their coordinates, what do they represent? So let's start with the x-intercept. The x-intercept would be, right here is 45, right? 45, we're going to write it down as 45, 0. You can say candle burns down, burns out, right? Burns up, whatever you want to say, after 45 minutes. And really, I don't care how you say it. You could say after 45 minutes, the candle will have reached a height of 0. Perfectly fine with that. Y-intercept. The y-intercept is up here, and it appears that my scale is 2, right? So this is 0, 10 here. So the y-intercept is 10, and that would be 0, 10. Initial height of candle is 10 centimeters. And I want to emphasize that when it's a word problem, you have to have labels and units attached if you want full marks, okay, if it's a word problem. What is the rate of change? I'm glad you asked, right? Let's go with the intercepts because those are also 2 points and they're very round numbers. Just stick with them. So I'm going to call this x1, y1, and I'm going to call this x2, y2. Okay? You should always do that because otherwise you're going to mix them up. If you don't do them in the order you're supposed to do them in, you might get the number right, but the sign will be off. Okay? That's why it's important to be consistent. If you wanted to call this x1, y1, and this x2, y2, that's fine, as long as you're consistent, okay? All right, so the rate of change Later, we're going to call this slope, by the way, chapter 6. Y2 minus Y1 over X2 minus X1. 10 minus 0 is 10. 0 minus 45 is negative 45. Okay. We can simplify that. 5 goes in here twice. 5 goes in here 9 times. So that'd be, and don't forget the negative. It follows you, but it always floats up for us. That's how I do it. This is still negative. Okay. And now that it's a word problem, there is a word problem, so we need to know the units. So my Y is centimeters per minute. Okay. Make sure you include units. Context, include units. You could have also said this. If you go 2 divided by 9, you get approximately negative 0.22 centimeters per minute. On average, right? That's an average burn rate. Okay. I'm fine just leaving it as a fraction. Just leave it as a fraction. I don't need you to get it into a decimal. Okay. What's the domain and range? And I should have left a lot more room here, but anyways, for domain, let's just go. I'm going to use the set here. We're going to go from 0 all the way to 45, and we're using t for x, right? That's 45, and the range is, by the way, the range, the lowest you get is 0. Okay, the lowest you get is 0, and they're using h for height, and the highest you get in terms of your y is 10. Okay, so always scan from the bottom up when you do your y, your domain, your range, and left to right when you do your domain. Then you're going to be fine there. And I think, yeah, we'll just make it to the end of this page. That's it for today. Use the intercepts and a third point to sketch this. We're going to sketch that here. Okay. So x-intercept, y is equal to 0. Y-intercept, x is equal to 0. And we're going to do our third point here. Okay, I'm going to block that off like this. So when y is equal to 0, we plug in 0 for y, right? And then we end up with negative 1/2 x plus 3. Bring the 3 over, subtracting. No, sorry. And then we're going to multiply both sides by 2 to get rid of this. So that's negative 6 is equal to, this cancels out, right? To negative x, really. Divide both sides by negative 1. X equal to 6. So 6, 0 is our x-intercept. Y-intercept. This is easier. Negative 1/2, 0. Show this step, right? It's important. And this whole thing will turn to 0, right? So it's really just 3, so it's 0, 3. And the third point, how about let x equal to, we're going to go negative 2. Let x equal to negative 2. And so we just, oh, I know why I picked negative 2. You'll see here. Negative 1/2 times -2. Watch what happens here. These two will cancel out. That's why I picked 2. So if there had been a 3 here or a 4 or whatever, that's probably the number that I would pick if it's a fraction to cancel them out. Okay? And then it's +3. So these two, got to be careful. These two negatives will turn positive, right? So this whole thing will be positive. You can cancel the 2's. So y is really, this whole thing is just +1 plus 3. So y is equal to 4. So when x is equal to -2, y is equal to 4. So these two here have zeros, right? But this one doesn't because I'm picking a different point. I picked x is equal to -2, right? So it's like a machine, right? You feed it and it gives you an output. Input, output, remember? X, Y, domain and range. So let's graph this. 0, 6 is up here. No, sorry. 6, 0. Common mistake though. 6, 0. 0, 3. -2, 4. There it is. And they line up. Okay, I'm gonna give you the homework. Notice this, the slope is negative and the line is pointing down from left to right. That's another thing, another clue that you should have, okay? So homework, I'm gonna get you to do page 319, 4 to 8, 10 to 12, and 14. Okay, make sure you write that down.